Hello everyone, and thank you for being here. I am Karim Bouassem, Doctor in Engineering Sciences from Faculty of Science in Hassan II University in Casablanca. And I am really pleased to share with you our contribution related to state and unknown input simultaneous estimation for a class of discrete time linear implicit models with an application on the heat exchanger pilot process. So first, a quick overview on what I will be talking about. I'm going to start with a bit of background and a problem statement. And then I will introduce the class of the system we are focusing on. Then I will present our approach and methodology for unknown input observer design and conclude with an illustrative example and some of my future work and perspectives. Our contribution focuses on the simultaneous estimation of unmeasurable states and unknown inputs for a class of discrete time linear descriptor system. Our approach is based on the separation between dynamic and static equations in the considered model. We are living in a time of unprecedented rapidity of change and the hyper-competitiveness in a global economy, where industry are either moving forward or failing behind. That's why industry becomes more and more complex with higher exigencies and requirements, mainly in the field of safety and security, reliability and efficiency, accuracy and data availability, environment and compliance with standards, cost reduction and operation optimization, availability and performance. This is a challenging situation for automation and process control engineering. It is in this context that we are focusing on the unknown input observer design, which is widely used in the area of fault detection and isolation, and also in the design of fault-tolerant control strategies. We focus our work on descriptor systems, which constitute a powerful modeling tool, allowing description of the dynamic behavior of physical phenomena for processes governed by both dynamic and static equations, such as the electrical networks, bioengineering, power systems, chemical processes, robotics, mobility, aerospace and engineering, and also in some social and economic systems. Here is an outline of the proposed strategy. So first we will consider the discrete time linear system subject to unknown inputs. Then the method permitting the separation between the dynamic equations and the recurrent relations in the model is exposed. Then an augmented explicit model which contains the dynamic relations and the unknown inputs is developed. Next, an unknown input observer design in an explicit structure is proposed. The exponential convergence of the state estimation error is studied by using Lyapunov theory, and stability conditions are given in terms of linear matrix inequalities. An illustrative example is given to show the observer performance and also the effectiveness of the approach. In this paper, the following discrete time linear descriptor model is considered, and the aim is to propose and develop an unknown input observer permitting the simultaneous estimation of both states and also the unknown inputs. In the considered class of system, lambda is a square matrix with a rank of lambda equal n1. Xk is the state vector composed by x1k and x2k, in which x1k is the vector of recurrent variables and x2k is the vector of algebraic variables with n equal n1 plus n2. Eta k, uk, and yk are respectively the unknown inputs, the control input, and also the measured output. Sigma, gamma, lambda, phi, and omega are real known constant matrix given as follow, in which sigma 22 are supposed invertible. Also, and before giving more details and going for and given the main results, let's make the following assumptions. Gamma sigma is regular. The model is impulse observable and detectable. And also we consider that the unknown inputs is constant by time interval means eta k plus 1 it equal eta k. In order to investigate the unknown input observer design, we proceed by the separation between the dynamic equations and the static equations in the model. Then the system can be rewritten as follow, in which M, N, P, R, S, and T are matrix given as follows. Let's now define the augmented state vector Xc1k and Xc2k, in which Xc1k includes both the dynamic and the unknown input, and Xc2k represents the static vector. The system can be written as follows, in which where M tilde, N tilde, G tilde, and R tilde are given as follows. The proposed unknown input observer takes the following form, where Xc1k, Xc2k is the estimated augmented state vector, and yk hat is the estimated output vector. J is the gain of the unknown input observer, determined such that the estimated augmented state vector asymptotically converge to Xc1k, Xc2k. Also, to determine the convergence conditions, we define the state estimation error epsilon k as follow. So from this equation we can easily find that to set the epsilon k convergence towards 0, it suffices that epsilon k1 converges to 0. The main result is stated in the following theorem. There exists an unknown input observer for the discrete time linear descriptor model or implicit model if a given alpha between 0 and 1, there exists matrix Q and Y verifying the following linear matrix inequalities. The observer gain J is given as follows. Regarding the theorem proof, as we said before, we will use the Lyapunov theory. So let's consider the following quadratic Lyapunov function as follows. So the estimation error convergence is exponentially ensured if the following condition is guaranteed. So which is equivalent to the following stability condition. So by using by setting the variable change as follows and using the Schur complement, we set the targeted linear matrix inequalities. In order to demonstrate the effectiveness and applicability of our proposed approach, we consider the example of a process of heat exchanger as described in the following figure. This system is supposed described by a discrete time linear model, descriptor model, subject to unknown input. The discrete time model is obtained by using Euler discretization method. The numerical values of all metrics are given as follows, and we can easily set that sigma 22 is inversible, so that we can use and apply our proposed approach for unknown inputs observer for the design. Following the main results, the simulation results, and we can see the states and their estimations, x1k and x4k and their estimates. x1k and x4k represents the temperatures, the hot and cold water temperatures. x2k and x5k and their estimates, which represents respectively the position of the valve of hot and the cold water. x3k and x6k and their estimates, they represent respectively the velocity of the vents in hot and then in cold water. x7k and x8k and their estimates, which represents respectively the acceleration of the valves in both hot and cold water. For the unknown input eta k with its estimates, we can see the good performance of the proposed observer, permitting the estimation and a good estimation of the unknown input. So to conclude, in this paper we proposed a method of unknown input observer design for a class of discrete time linear descriptor system subject to unknown inputs, which affects both state and output of the model. The proposed result permitting to estimate simultaneously the system state and the unknown input is based on the separation between dynamic and static equations in the considered descriptor model. The exponential convergence of the state estimation error is studied by using the Lyapunov theory, and the existence of the conditions ensuring the convergence is expressed in terms of linear matrix inequalities. For the perspective and future work, we are focusing on to extend our result to a nonlinear case, and also to investigate the fault-tolerant control and fault detection and isolation applications. Thank you so much for your attention, and I will be more than happy to receive and to have your comments or questions. Thank you.